Hello everyone, this video is going to get us started into Chapter 3. Now Chapter 3 is all about stoichiometry, and stoichiometry is the process of doing mathematical calculations with chemical equations. But before we can get there, we need to learn a few key fundamental skills. Now before we get started, I just want to outline what we're going to go over. So by the end of this video, you should be able to understand these three key points. The first one being to understand the anatomy of a chemical equation, to learn how to balance chemical equations, and to be able to identify three important types of chemical reactions. So let's work on the first goal. Here I have written out a chemical equation. Now there are a few terms that I need to introduce to you all so that we'll be able to talk about chemical reactions a little bit more fluently. Now, everything that appears to the left side of the arrow is called a reactant. And everything that appears on the right side of an arrow is called a product. Now these terms don't change. So in any reaction we look at, whatever's on the left is called a reactant, and whatever's on the right is called a product. Now this arrow, we read this as yields. So if I were to read this chemical reaction out loud, I would say N2O5 plus H2O yields to HNO3. That's how we would say that. Now, if you notice, I have these little letters here written in parentheses as subscripts behind each molecule, and those are called phases. Or you might also see them called states. And that lets us know what phase or what state the molecule that we have in this reaction is in. So we need to be able to understand what each of these little letters mean. Now, these letters are always written like this, as subscripts after the molecule in parentheses. So let's go over them. So G stands for gas. This lowercase cursive L stands for liquid. S, which is not in this reaction, stands for solid. And finally, AQ means aqueous. And that means that something is in a solution. Now, the last term we need to be able to identify is this number right here. And that number is called a coefficient. Now, we use coefficients to balance chemical reactions. We can add or take away coefficients, but we cannot change the subscripts here. We cannot alter those when we're balancing chemical reactions. We can only change coefficients. So that covers the anatomy of a chemical reaction. So now let's look at how we balance chemical reactions. So here I have a reaction for us to work on. Now, the goal of balancing a chemical reaction is to make sure that you have the same amount of elements as reactants as you do as products. And one tool that we can do to help us achieve this is like a little bookkeeping method where we write down every element that we have as a reactant and a product and how many of those elements we have. So let me show you what I'm talking about. If I look at my reactants, what are the elements that I have? I have carbon, and I have hydrogen, and I have oxygen. Now, because of the law of conservation of mass, we're also going to have those exact same elements as products. Carbon, hydrogen, and oxygen. Now, the next step is to take a look and see how many of each element I have as reactants and how many I have as products. So let's take a look at the reactants first. If I look at carbon, we see that I only have one carbon. So I'm going to put a 1 right here. If we look at hydrogen, we see that I have 4 hydrogens. So I'm going to put a 4 right here. Now if we look at oxygen, we see that I have 2 oxygens. So I'm going to put a 2 right here. Okay, so we have our reactants. Now let's look at our products. I have 1 carbon. I have 2 hydrogens. And I have 1, 2, 3 oxygens. Okay, so now we have our starting numbers, and this helps us see what it is that we have to balance. So if we look at each element, we can already see that carbon's already balanced because we have 1 carbon as a reactant and 1 carbon as a product. Now what's not balanced is hydrogen and oxygen because we have 4 hydrogens as reactants and only 2 on the product side, and we have 2 oxygens on our reactant side, but we have 3 on our product side. So let's take a look at hydrogen. I have 4 on the reactant side and 2 on the product side. Now I need to do something with a coefficient in order to make 4 hydrogens as a product. Now what I can do is to put a coefficient of 2 in front of the water here. And what that does is creates 4 hydrogen because we multiply coefficients by subscripts. So I take this 2 and I multiply it by that 2 to give me 4. So now this hydrogen changes to 4, and hydrogen is now balanced. Now, one really important thing here is to keep in mind is that this coefficient not only applies to hydrogen, but it also applies to oxygen. So when you add a coefficient to something, it applies to the entire molecule. So what that did is it influenced the number of oxygens that we have as products as well. So we have 2 oxygens right here now because of this coefficient, and we have another 2 oxygens right here from the CO2, giving us a total of 4 oxygens. So now we have 4 oxygens as products and only 2 as reactants. So we need 2 more on our reactant side. Now one way I can do that, actually the only way I can do that, is to add a coefficient of a 2 in front of the oxygen, because 2 times 2 is 4. So now if we take a look at our numbers, we have 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, and 4 oxygens. Now if we erase our little scratch work here, we are left with a balanced chemical reaction. Not too bad, right? Okay, well let's look at one that was a little more difficult. This is a reaction that was in our group problem from today. Now I'm going to approach it the same way. So the first thing I'm going to do is I'm going to write down how many elements, the elements that I have on both sides of the reaction. So I have aluminum, I have oxygen, I have hydrogen, and I have sulfur. So now I'm going to have the same elements on our product side. Now let's get our starting tallies. How many aluminums do I have on the reactant side? Just 1. So I'm going to put a 1. Now how many oxygens do I have on the reactant side? Keep in mind this subscript 3 right here distributes to both the oxygen and the hydrogen. So I have 3 oxygens here and another 4 right here. So that gives me a total of 7 oxygens. Now, same thing with the hydrogen. I'm going to have 3 hydrogens right here, plus another 2 right here, giving me 5 hydrogens. Now finally, let's take a look at sulfur, and we only have 1. Okay, now let's do the same thing for the product side. I have 2 aluminums. I have 4 times 3 is 12 oxygens, plus another one right here, giving me 13. And for hydrogen, I have 2. And for sulfur, I have 3 right here. Okay, so now we have our tallies for all of the elements in this reaction. Now we can start to balance. Now, if I start just what we have at the top, if I look at aluminum, I have one aluminum as a reactant and 2 as a product. So if I want those to match, I can add a 2 right here in front of the aluminum. So now that gives me 2 aluminums, but keep in mind when you add a coefficient, it affects everything that comes behind it. So now I have to recount my oxygens and my hydrogens. So adding that 2 coefficient there now gave me 6 oxygens right here, because 3 times 2 is 6, plus 4. So now I have a total of 10 oxygens. Now we need to do the same thing for hydrogen. 3 times 2 is 6 for the hydrogens, plus 2 more right here, giving me 8. Okay, so now I have updated numbers. Now, one tip that I can give you guys about balancing equations, there's really no right or wrong way to do it. It's just a process of trial and error. But if we look at the elements we have a lot of oxygens and a lot of hydrogens. So I would leave those last to balance, and I would balance aluminum and sulfur first because we have the least amount of them. So we already balanced aluminum, so now I'm going to jump down here to sulfur. We have 1 sulfur as a reactant, but 3 as a product. So I need to have 3 as a reactant as well. So I can add a coefficient of 3 right here, and that gives me 3 sulfurs. But now I once again changed the amount of hydrogens and oxygens that I have, because this 3 influences this hydrogen right here and this oxygen. So I have to recount them once again. So I have 6 oxygens right here, 2 times 3, and I have 12 right here, 3 times 4. So that gives me a total of 18 oxygens. Now, for hydrogen, I go through the same process. 2 times 3, 6 hydrogens here, and 3 times 2, 6 hydrogens here. So now I have a total of 12 hydrogens. So let's just kind of take a quick recap where we are at this point. My aluminums are balanced, and my sulfurs are balanced, but my oxygens and my hydrogens are not. Now, if you notice here, for this oxygen, we have an odd number. Now, odd numbers can be a little bit more difficult to deal with in balancing chemical equations, so my recommendation is that you leave the odd number element for last in hopes that influencing or that changing the coefficients of the other elements will help, will just kind of, it'll work itself out. So you'll see what I mean as we go through the rest of this equation. So since I have an odd number of oxygens, I'm going to take a look at hydrogens first. So I have 12 hydrogens as reactants, but only 2 as products. So hydrogen only appears in one place on the product side right here. So what's a coefficient that I can put in front of this water molecule, in front of this H2, that will give me 12 hydrogens? A 6, right? If I put a 6 here, 6 times 2 is 12. And that gives me now 12 hydrogens. So my hydrogen is now balanced. But remember, coefficients affect everything in that molecule. So this 6 also affects this oxygen. So if I look right here, I have 6 oxygens here and 12 here. 12 plus 6 is 18, and look what happened. That odd number just worked itself out just because I changed the hydrogen. So now my oxygens are balanced. So just let's go through the numbers real quick to make sure everything's balanced. 2 aluminums, 18 oxygens, 18 oxygens, 12 hydrogens, 12 hydrogens, 3 sulfur, and 3 sulfur. Looking good. So I can erase my scratch work here, and what we are left with is a balanced chemical reaction. So that was an overview of how to balance chemical reactions. Now, to get good at balancing chemical reactions is just a matter of practicing. You have to go through a lot, and as you do, you'll see that it gets easier. So now let's move on to the third and final goal of this video, and that is being able to identify 3 different types of reactions. Now, the first reaction we're going to look at is called a combination reaction. And a combination reaction is when multiple reactants combine to form one product. So let me give you 2 examples of this. So here's the first example. 2Mg plus O2 yields 2MgO. And this reaction is balanced already, just in case you were curious. So this is a combination reaction because we have multiple reactants, in this case 2, that are combining, they're coming together and combining to form one product. So that's a combination reaction. Let me give you another example. C3H6 plus Br2 yielding C3H6Br2. Now this is another example of a combination reaction because again, we have multiple reactants that are coming together and just forming one product. So that is combination. Now let's look at decomposition. Decomposition is the exact opposite. So decomposition is when one reactant breaks down into multiple products. So an example of a decomposition reaction would be CaCO3 yielding CaO plus CO2. Now this is a decomposition reaction because we have one reactant that's breaking down into multiple products, in this case 2 products. Let me give you one more example. 2KClO3 yielding 2KCl plus 3O2. Now here again, this is a decomposition because we have one reactant that's breaking down into multiple products. Now, finally, the last type of reaction that you need to be able to identify is called a combustion reaction. And a combustion reaction always follows this formula. And the formula is a hydrocarbon. And a hydrocarbon is something that's made up of just carbon and just hydrogen, hence the name hydrocarbon. So a hydrocarbon plus O2 yielding CO2 and water. So a combustion reaction is always going to be in this formula. The only thing that's going to change is what the hydrocarbon is. So an example of a combustion reaction would be C3H8 plus O2 yielding CO2 and water. So this is a combustion reaction because we have this O2 yielding CO2 and water component here, and we have a hydrocarbon. So the O2 yielding CO2 and water is always going to be there in a combustion reaction. It's always going to be the same. The only thing that's going to change is this hydrocarbon up front. That could be anything that's made of just hydrogens and carbons. So that's it for this first video. Hopefully you feel good about the 3 goals that I mentioned in the beginning. You feel comfortable with terms, anatomy of chemical reactions. You feel okay with balancing chemical reactions, and you will be able to identify these 3 types of chemical reactions. One thing to keep in mind about these 3 reactions is that don't stress out if you come across a reaction that doesn't fit into one of these 3 categories, because there are actually a lot of different types of reactions that exist. We'll learn about a couple more later on in the semester. But for right now, your main goal is to be able to identify these 3. Alright, so that's it for this video. I hope it was helpful to you guys. If for any reason something wasn't clear or I didn't explain it very well, feel free to reach out to me and I will try to explain it to you in a different way. Alright, see you soon.